Welcome back. This is Mrs. Rubright with Algebra 1 Honors. Today's lesson is 6-4, adding and subtracting polynomials. So in order to add or subtract polynomials, ultimately you're just combining like terms. So we have all of this being added, and they can align them vertically. So when they do that, you bring down your 4x cubed. You have 12x squared plus 5x squared, so that's 17x squared. You have 8x's minus 6x's, you have 2x's left. And then 6 plus 9 is 15. So you're just adding the like terms. Another way that you can do this is just doing it horizontally. So if you're doing it horizontally, you have negative 7x squared plus 1x squared is 8x squared. Or sorry, negative 6x squared, because one of those was negative, right? Negative 7 plus 1 is negative 6, negative 6x squared. All right, and then for your plus 2x minus 2x, those are going to cancel each other out, leaving you with 0x. And then your constant, you just have 1, and it's positive 5. So when you combine these, you get negative 6x squared plus 5. Personally, how I show my work on these is I would just go like, okay, these cancel each other out, and I have negative 6x squared plus 5 done. Do you get the same result whether you add the polynomials vertically or horizontally? Why or why not? Yes, because you're doing the same thing. You are combining like terms either way. Like terms with both methods. Is the sum of two polynomials always another polynomial? Explain. Okay, so yes. The two addends consist of a sum of monomials. After adding, the result also consists of a sum of monomials. So it's a polynomial. Is the sum of two polynomials of degree 5 always a polynomial of degree 5? Give an example and explain your answer. No. So here's your example. If I had x to the 5th plus 3x plus negative x to the 5th plus 6x, that would give me 9x because these cancel out. And 9x is a degree 1, right? So if your 5th degree ends up canceling each other out, then no, it wouldn't be a 5th degree because that might be a term that cancels out. Subtracting polynomials. So when you're subtracting polynomials, we're going to once again line them up. So we're writing them in descending order. Squared to the first degree, nothing, right? Squared to the first, nothing. All right, so minus a negative is plus, right? You're distributing this out. Minus a negative is plus. Minus a positive is minus. So 9x squared plus 6x is 15x squared plus 3x, 0 plus 3 is 0, is 3, sorry, and 2 minus 1 is 1. So we have 15x squared plus 3x plus 1. All right, so I personally like the horizontal method. So all I'm doing is I'm distributing this negative, which basically changes everybody's signs, right? If you're multiplying everything by negative 1, because there's an imaginary 1 out there, you're changing everybody's signs. So this was positive, now it's negative. It was positive, now it's negative. It was negative, now it's positive. It was positive, now it's negative, right? Change everybody's signs, combine like terms. So the x cubes squares x's and our constants. Right, so 6x cubed minus 4x cubed is 2x cubed. 3 minus 6 is negative 3. 2 plus 2 is 4. and 9 minus 7 is 2. Okay, how is subtracting polynomials similar to subtracting integers? So, you subtract integers by adding the opposite of the subtracted integer. You subtract polynomials the same way. In part A, you leave a gap in the polynomial 9x squared plus 2 when you write the subtraction problem vertically. Why? Because there is no x to the first term. And you're lining them up vertically. Is the difference of two polynomials always another polynomial? Explain. Yes. Because the sum of two polynomials is always another polynomial. Modeling high school populations. According to data from the U.S. Census Bureau, for a period of 2000 to 2007, the number of male students enrolled in high school in the U.S. can be approximated by the function m of x equals negative 0.004x cubed plus 0.037x squared plus 0.049x plus 8.11, where x is the number of years since 2000, and m of x is the number of male students in millions. The number of female students enrolled in high school in the United States can be approximated by the function blah, 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 where x is the number of years since 2000 and f of x is the number of female students in millions. Estimate the total number of students enrolled in high school in the U.S. in 2007. Make a plan. The problem asks the total number of students in 2007. First find t of x equals m of x plus f of x to find the model for total enrollment. Then evaluate t of x at an approximate value of x to find the total enrollment in 2007. So they're writing the polynomials, aligning the terms. All right, so when we add these, we get negative 0.01 x cubed plus 0.066 x squared plus 0.214x plus 15.78. Okay, so our t of x equals negative 0.01 x cubed plus 0.066 x squared plus 0.214x plus 15.78. Evaluate t of x. All right, so evaluate t of x. For 2007, x equals 7. Use a calculator to evaluate t of 7. Round to one decimal place. Okay? So if we're plugging in a 7 for x, so literally we're taking this and we're going like this. 7 to the third plus 0.0667 squared plus 0.214 times 7 plus 15.78. You're going to put all of that into your calculator. So I want you guys to try this out now. So 7 to the third. Do you guys know how to do that part in your calculator? All right, so 7 to the third is 343. So I'm doing that times 0.01 negative equals, I get negative 3.43 plus 7 squared times 0.066, 3.234 plus 7 times 0.214, 1.498, plus 15.78. So I got 17.082. To one decimal place, 17.1. You guys able to get that? You can use your storage buttons. You can use your parentheses buttons. So like if you wanted to do this as 7 cubed times 0.01 negative equals plus parentheses 49 times 0.066 parentheses equals plus parentheses 0.214 times 7 parentheses equals plus 15.78 equals, and you get your answer without having to write down those in-between numbers. So there were approximately blank high school students in 2007. So there was approximately 17,100,000. Because it said in millions. 17,100,000. Is it possible to solve this problem without adding the polynomials? Explain. Yes. You can evaluate m sub x and f sub x separately for x equals 7, and then add the results. Explain how you can use the information to estimate how many more male students than female students there were in the United States in 2007. So first you would find d of x equals m of x minus f of x. Then evaluate d of x for x equals 7. You're going to have d of x equals m of x minus f of x, which equals your equation. Okay, so d of 7 equals 0.7. So there is approximately 700,000 more male students than female students in 2007. All right, so we're just going to do a few practice problems. We have like 2 minutes left, so we're going to do maybe like 2 of these. And then your homework tonight is the 347 and 348. All right, so let's do like 2 of these. So let's do an addition and a subtraction. How about number 1 and number 5? All right, so 2x to the 4th minus 1x to the 4th is 1x to the 4th, or x to the 4th. Negative 6x squared plus 6x squared is negative 3x squared. 8 minus 12 is what? Negative 4. And that is how you add. For subtraction, we turn it into addition, change everybody's signs, and then combine like terms. 2x to the 4th plus 1x to the 4th is 3x to the 4th. Negative x squared minus, plus negative 5x squared is negative 11x squared. 8 plus 12 is 20. And that is how you add and subtract polynomials. I hope you guys enjoyed this lesson. Please like and subscribe and have a fantastic day.